Can you imagine running Apache web server on Docker container this quick? Just 1 second is all it takes to start a Docker container running a web server, and if we check our browser, our web server is already up and running. Now let's break it down. In the last two videos, I showed you how to install Docker Engine, the brain of running containers on Windows, Linux, and Mac OS. In this video, we're gonna continue on, and first we're gonna explore how we were able to start a web server using Docker container, and we're also gonna discuss how storage works inside Docker containers between the bind mount method and the persistent volumes. And finally, we're gonna see how we can use Docker Compose, which is an infrastructure as code utility or an automation utility that allow you to run multiple containers and multiple stacks of services at once using a simple configuration file in YAML format and also just one command in the command line. Let's get started. First off, if you haven't installed Docker Engine on your system already, check back the older two videos on Docker Engine for Linux and Windows environment. I'll also put the paste pin in the description below, which help you have the quick command list that you need to enter in the system to get the Docker engine running in your system. After your Docker engine has been installed, you will always use the Docker Hub website. You can find different images and software that you can use inside a container. Now I just searched for Apache, which is the famous web server, and they have an image for HTTP daemon, which allow you to run an HTTP server quickly inside Docker. Now, if you go down, you will find the symbol instruction files in here, which allow you to use the docker run command to start a container. And it has a symbol argument of name, port mapping, and we addressed port mapping in the last episode. And finally, this statement that has to do with the storage. So first off, we copied this command and we took it to PowerShell and we paste it. Now the name, you can choose whatever name you want for the board. You just need to make sure you find a board that is not being occupied already. Like in this time, we are already using board 47s, so I cannot start another container on the same board because it's already occupied. And the number on the left always represent the listener on the host system. In this case, I'm using Windows 10 with the Docker engine. So therefore, Windows 10 will listen in port 8080, and the Docker API will send the request back to the container inside on port 80. So the port on the right is the listening port inside the container. Now, following the port mapping, we have a -v flag, and this is a flag you use to define storage option. And you can see in this case, it's very similar to the port mapping. We're gonna be assigning a folder in our Windows environment, which is defined by the pwd or print working directory. In this case, I am in my user folder desktop and inside a folder called sandbox. So this folder or this full path will be pointing at this folder inside the container, which is basically our HTTP root folder. So this is simply allowing me to have a local folder on my Windows and have all the files in this folder accessible inside the container. Now keep that in mind when you use print working directory, because if you're opening PowerShell for the first time, let's try it right now. Notice when you run a PowerShell fresh screen, you are in the system32 folder. If you paste the docker run command and assign the print working directory right away to the web server, this is a major mistake because you are essentially opening your system32 folder to your web server. Let's test it out. Now, as you see, the first time I ran it, it's rejecting the command altogether because the print working directory syntax works in Linux this way, but it needs a small modification to work on Windows. What I'm gonna do is I'm gonna go up arrow to bring up the same command one more time. And what we need to do is to remove the quotation mark, and we're just gonna use this kind of bracket, and also one more time before the word pwd. And this is the syntax that PowerShell understands to print the working directory. So if we hit enter this way, now our server is working properly. We can check in the Docker and we have here our new created server. Now this server is listening on port 8080. So if we go ahead and check the server this way, As you see right now, I'm inside my system32 folder. I see all the system critical files. That's why it's a terrible idea to start a container using a bind mount to a system folder. Now, to avoid this issue, first you need to change your directory before you start running containers from system32 to something else. Maybe go into the C folder and then start going around. Or you can also use the full path to your folder directly inside the -v statement so that you can define the folder right away without using the current directory. So let's try this out. I'm gonna remove the print working directory command. I'm just gonna put a full path. So I know this is my folder where I'm pasting my web server files. I'm just gonna copy the full path for the folder and I'm gonna put it in here. So now my sandbox folder with the full path is assigned to the htdocs root http folder inside the container. So now once I hit enter and we go back to our server, now I'm only getting the correct directory to show up and I'm not binding the system folder to my web server. Now let's wipe this container also. And I want to show you the print working directory will also not work with the Docker Hub syntax inside command prompt. If you prefer to use command prompt to start up containers, you will also need to do some adjustment to the syntax to make it work properly. Now first let's define the right folder because right now we are in the root of our user. So let's go into desktop and let's go inside the sandbox folder. And let's use the same syntax that was on the Docker Hub website using the print working directory inside quotation. And this one will also get rejected because this is not the right syntax. So the way you can do this in command prompt, you basically need to replace the whole print working directory using just a simpler syntax, which is %cd %, and this is basically the same as print working directory inside Linux. So once we do this, now our system will start properly and our containers will also still load the sandbox folder after creating it using the command prompt. Remember to change the print working directory to either cd or with the brackets inside PowerShell. So now we check the first storage option with container, which is bind mount. Now let's look into the login feature. So as we are running a web server, you might be wondering how you can simply access the logs from the web server so you can identify issue or you can see if traffic is going through. You can simply use the command docker logs and then the name of the container you are trying to check. So right now let's check the second web server we just started, which is my Apache app. You can see here some reporting that happened inside the server and also our first GET request, which reported the 200 successful code. And as more requests come to the system, we always use this command docker logs container name, and this will always show us the web server logs coming from inside the container right away to the Docker API. Now this is not limited only to the web server application logs. We can also see things like CPU RAM usage as you would see with a normal virtual machine. Now let's do the command docker stats this time. And the docker stats is similar to htop or any CPU RAM monitoring utility. You can simply see the containers. You can see their very low usage in the CPU, the memory, and also the network input output. So this is a very simple way to check the CPU and RAM usage for your container using the docker stats command, and also to check the application logs using the docker logs and then the container name. Now let's look for a service like WordPress where you are required to have multiple components or multiple applications and services running to be able to get the WordPress running. And those are simply a web server, a database server, and finally a PHP compiler. So in this case, we need 3 pieces of services to run to make a WordPress or a blog website working. So let's open up and let's see in here, there's multiple versions and multiple varieties in here, and there's also a lot of customization, but we are simply given either a simple way to use a docker run command to start a WordPress container, and also you have to feed it the database yourself if you are already running a database container or a full database server. But there is also a feature called Docker Compose, which is simply an infrastructure as a code utility that allows you to run a YAML configuration file similar to an XML file. And you just give it an instruction which services you need and which information you need to pass to those services to start this container. Now, if you're using Windows, this will be already installed with the system. You can verify this using the Docker -compose, and then you can do the flag version to verify if you have this utility installed. You can see in here I have version 1.25, and if you're running Linux, you might need just a few lines of installation to get the Docker Compose utility inside the system. So it doesn't come pre-installed in Linux, but it does on Windows. Now if we go down, we can see even a script in here for Docker Compose. And you can see in here, this is just a simple text file that contains multiple services. And our first service is WordPress. It's using the WordPress image and it's assigning it port 8080 for our host machine, our Windows 10. And port 80 is the listening port inside this Docker container. And we're also passing a few environment variables like the database and the database user, database password, database name. And this time, instead of using a bind mount, this is actually creating a persistent volume inside the Docker folder. And based on the Docker website, they prefer the volume option rather than the bind volumes because this is persistent solution that is better and can be attached to different containers. So in this case, it's creating a volume inside the volume directory. It's calling it WordPress, and it's also binding this volume to var www.html inside our WordPress container. Think of this container as the web server and the PHP binary together, and then comes out the database, which is the second service being installed by this stack. So in this case, we're using MySQL version 5.7. We're also adding a few environment variables. Those are the databases that are going to be created because they are already passed to the WordPress. So we have to match this database configuration between both ends. And finally, it's also creating a volume for our database and pointing it to the container var library MySQL folder. So in this case, we are building everything on the go, the MySQL database, the WordPress, and the PHP compiler. So now let's try to run this stack and I'll show you how easy it is to start this service. So we're gonna copy this text and let's go back to our sandbox folder. We're gonna create a new text file. This one we can call it stack.yaml and we're just gonna edit it with the Notepad++. Now inside the Notepad+, I'm pasting the script. You can make modification to the file if you prefer. Example, right now we already have a server running on port 8080. So now let's try a different port for this WordPress instance so that we don't cause a conflict. I'm going to change the port to 31,000. So in this case, my Windows 10 will listen on port 31,000, my container will listen on port 80, and Docker will make sure the communication goes through between my Windows host and my Docker container. We can also change any of the database if we prefer not to use these default names. For example, this is the database name. Let's call this WordPress database. And we also gotta make sure we are passing this parameter to the MySQL container as it gets created so that the WordPress can have a successful communication to the database. So I made sure the name matches for the database name. And finally, we can save this file. Now to deploy this YAML file, it's super easy. All we need to do is to use the docker-compose command. Then we're going to use a flag-f to define the stack.yaml file. And we're just going to write the file name. And finally, we're going to say up. If we hit enter, this will start downloading the images for the WordPress and the database. You can see in here, I run it in attach mode so that I can see all the debug information. This is simply downloading the image, creating the database, and connecting the server. So now it seems like there is no more output coming, and it simply created the sandbox stack. As you see here, this is a different icon for this particular image. And if we expand it, now we see the WordPress onboard 31,000 and the database supporting the WordPress. So this tag was able to simply create the two containers, create the database, and modify the WordPress configuration to match this new database. So now we should be able to test out this connection. I'm gonna go into my web server, and this time instead of using port 8080, I'm just gonna use port 31,000. You can see here this quickly jump into the WordPress installation. I'm able to define my site title and my admin username. That's how simple it was to start the WordPress container using this tag, because this is much faster than any other way you can do it. And it's great to use the Docker Compose utility to build multiple services together and be able to talk in between with the least amount of effort. Now, we talked about this containing volumes, but how do you access these volumes? First, when we did the bind mount, we used this folder, so we know our files were already in here. But when this tag used volumes, as we seen in the stack file, we seen in here this volume and we seen this volume. But how do we get to these folders? And this is where we're gonna get some variety, because if you are using Docker on Windows using the old backbone Hyper-V, you will have a different location for the volume folder. But if you are using the Windows subsystem for Linux version 2, which is the one we recommend, you can simply find this using the Windows subsystem for Linux mount. I want to show you how to get to that so you can see all your web server files. So I want to go into my run command and I want to run this address. There's going to be a network location, so you have to put the double slashes in the beginning, and then you have to write WSL for Windows subsystem for Linux, $. And once you enter this, you will be given these two network shares folder where they are actually the Docker mount for the Windows subsystem for Linux. And we're simply gonna go to Docker desktop data. Inside of here, we have multiple folders, but we have our mount folder in here. And inside the mount folder, we're gonna go into Windows subsystem for Linux. One more time into Docker desktop data. And then there is also a data folder inside. From here, we need to go into Docker and finally into volumes. So it's really long path, but if you are wondering how to get to the volume path on Windows subsystem for Linux version 2 equipped systems, this is where you need to go. WSL $, Docker desktop data, mount, WSL, Docker desktop data again, data, Docker volumes. You don't want to write this whole thing every time. You can simply drag it to the desktop to create a shortcut. And every time you want to access it, you can use the shortcut. But inside of here, I seen here the two volumes that are created for both the database and the WordPress. Once you go inside the sandbox WordPress underscore data, in here you'll see your root folder for the WordPress, like the index.php, the configuration files, all the files that you need. If you want to create themes or add plugins, you would just copy them to this folder from here, as normal as you do with any web server. Now remember, we did the Docker Compose using the attach mode. That means right now I'm attached to the system, like I get all the terminal output from inside the WordPress or MySQL, and this is good for debugging or for checking something for the first time. But the problem with this is once I break out of my terminal, like if I Control and C out of this, it will automatically stop the stack and it will remove everything. Like as you see in here, it's exited. So we can delete it now. And I want to show you the normal way you would use for everyday containers. So instead of using the Docker compose -f file name up command, we're going to add something in n-d, which is detach. And detach means it's going to run persistently. You don't have to keep using the terminal or stuck to the terminal output. And when you run this, it's going to do the same thing, this time a lot faster because we have the image locally. Now our WordPress is back up again. We can verify this and everything is working. Now let's move to the Linux environment and let's try the same thing, running a Docker Compose stack to run a WordPress server and a MySQL server together using the stack.yaml script. So I have my stack.yaml script listed in the folder in here. So I'm going to use the command sudo docker compose. and then I'm gonna use the flag -f. Tag.yaml is the file name containing the instruction, and finally up and then -d for detach mode. This will run the same thing really quickly, and we have the server in here. Now in the Linux environment, getting to the volumes folder is much easier. All you need to go is to go into your root folder, then you need to go into var, library. In here there is a Docker folder. Inside the Docker folder, there is the volumes folder. And in here you'll see all the different volumes that belong to your containers, like the WordPress and underscore data would contain all our PHP file, or index.php, everything. And also in the database side, we will see all folders inside the var lib mysql folder inside the container. Now it's also important to know that these volumes don't get deleted with the container deletion. For example, if we go back in here to our terminal and we need to stop these containers from running, so we're gonna do a sudo docker ps, which shows us all the containers that we are running. And in here we can see our WordPress and MySQL, both containers are in running state. So we're gonna copy the names for both of our containers. And the proper way to remove a container is to go and stop it first. So we're gonna use sudo docker stop, and we're gonna base the name of the container. This takes care of just turning it off. So as you see right now, my database is off. Now I can go as well and remove it using docker rm and then the container name. Now we can see our container got removed. Now we can do the same thing with our WordPress container name. This is the way Docker lets you know that this command has successfully happened because it's showing you the same name back. So now after we stop our second container, we're just gonna do the rm to remove it completely. Now our containers are gone. If we go back to check our current running containers using docker ps, we only have our Pi-hole from before, and both containers for WordPress have been removed. That doesn't mean the volumes have been removed, because if we go back to our files, we can see in here the folders for the database and the WordPress are still existent. They were not removed. That's why they are called persistent storage, because even after the container gets removed, I can simply copy this volume mount point and I can attach it to a new container. But if you really want to get rid of these files permanently, you're going to have to do that manually. And for this, we're going to use the sudo, and then we're going to use the docker volume. And inside the Docker volume, there are multiple useful things you can do. You can either create volumes for future use. You can list them, like you do the ls command, and you can see in here, those are the two container storage volumes that we removed, but the storage is still persistent. So in case you want to check a specific one also, you can use, instead of list, you can use inspect. That allow you to look inside one of these volumes to know all the details about that specific volume. So I want to do the first one, for example, our database. And this is showing me what time was it created, what kind of labels were attached to it, and also the main important thing is the mount point, which is inside the var library docker volumes. Is the same folder we have in here, var library docker volumes, and inside the underscore data folder. So in order for me to remove something, I just gonna go the same command, and instead of inspect, I'm gonna do docker volume rm. This way, it's just removing the volume, and as long as it returned back the name of the volume to me, that means that had succeeded. So I'm also gonna remove the other one, which is the WordPress volume, using the docker volume rm. Same thing happened. Now all our old storage volumes are gone. We can simply do the list one more time, and now our system is clean. So now we were able to remove the containers and also remove their attached storage. So now if we do a refresh in the volumes folder, now the data is permanently gone. Now, similar to the Linux environment, we can simply in here remove the containers directly from the GUI, or using the stop and then rm commands we did on the Linux. But in here, since it's more convenient, let's just remove it this way. And this will take care of removing the WordPress environment. Now our blog will no longer work. And if we go into PowerShell and we use the command docker volume list, in here we see the persistent volume still inside our Docker directory, even though the containers were deleted. We can do the same command docker volume rm. And this time we can actually define multiple names instead of writing one by one. So I'm gonna do sandbox underscore dp, and this was my first volume. And my second volume is the sandbox underscore WordPress. And once I hit enter, now it returned back both names for me. That means both got deleted. I'm gonna go up with the arrow 2 more times to go back to my volume list. And now all my volumes are gone. And this was the difference between running a Docker container using a bind mount versus a persistent volume, and also how to use Docker Compose to run stacks and multiple containers using a simple configuration file and a simple command. Thank you for watching.